Welcome to our channel. So today we are going to continue with our physics revision. So here we are having this question paper. This one is June 2025 session, physics paper 2. Okay, so I do believe, guys, that you have already done this paper before, so that you can make use of this session to improve yourself, to improve the way you can approach certain questions, the certain concept of physics. Okay, so I do believe also that you always read these instructions to candidates whenever you open a question paper, because it is very useful. So in this question paper we are having two composite sections, A and B, and in section A we answer all questions, and in section B we are given these questions number 9, 10, 11 and 12. Okay, so the number of marks is given in brackets at the end of each section, but today we are going to put more of our focus on section B. So we are answering section B of this question paper. Okay, so in section B we are required to answer any 3 questions from this section, and we are writing our answers on a separate answer booklet provided. So let us start with the number 9 of our section B. So this one, it is our first question. So we are required to explain the term stability of an object. So stability refers to the ability of an object, system or person to maintain balance, firm or unchanged when exposed to external forces or disturbance. So in other words, we are trying to say stability means the tendency of a body to return to its original position after being slightly disturbed, and in general stability is all about resistance to change and the ability to maintain balance or function properly under pressure. Okay, so to write our answer, we can now say stability. We can now say stability. So it's stability. Stability means the tendency. It is the tendency of a body to return to its original position after being slightly disturbed. So here is our definition for the term stability, and let us move on to the next part of our question, the item 2, which says state 2 ways in which the stability of an object can be increased. So we can increase the stability of an object by lowering the center of gravity of that object. So to lower the center of gravity makes the object more stable, and we can also increase or widen the base of the object. So the broader the base of support improves balance, and another way of increasing the stability of an object is to add weight at the bottom. So this increases the resistance to tipping. So adding weight at the bottom increases the resistance to tipping. And another way of increasing the stability of an object, it is to use support structures like braces or anchors, which helps to resist motion. Okay, so in this case, the most common ways of increasing stability, number 1, we have lowering. So we lower the center of mass or the center of gravity, the center of gravity. Okay, and the second one, we widen the base. Widen the base. Okay, so these are the most common ways of increasing the stability of an object. And let us move on to the third part of our question, which says a force is used to displace a cone as shown in fig 9.1. So we are having this force here, and this is weight of this cone, and we are required to explain how the cone regains its stability. So if there's a force that is pushing this cone in this direction, So for this cone to maintain its or regain its stability, this center of gravity here, this center of gravity must be always within the base, that is in contact with the ground. So to explain this, we can say for this cone to regain its stability, this center of mass, or the center of gravity, must always be within the surface area, that is in contact with the ground. Okay, so to explain how the cone regains its stability, it is that the center of gravity must be always within the surface area. So it is within the surface area that is in contact with the ground. So this is our answer for item 3 of number 9. Okay, and let us move on to the next question, which requires us to explain why luggage compartments of a bus should be at the bottom of the bus. Okay, so to explain this, we are going to use the idea that putting the luggage on the compartment of the bus that is at the bottom decreases the center of gravity of the bus. So by decreasing the center of gravity of the bus, this increases the resistance to tipping. Okay, so the idea is to decrease the center of gravity and then increase the resistance to tipping. So to write your answer, the first thing you need to write is to to put luggage on a compartment of the bus at the bottom decreases the center of gravity. Okay, and the second point is that this then increases the resistance to tipping. Okay, so here is our answer for this item here, to explain why the luggage compartment of a bus should be at the bottom of the bus. So the idea is to decrease the center of gravity, and then the decrease in center of gravity then increase the resistance to tipping of the bus. Okay, and let us move on to the next part of our question, part B, which says Fig 9.2 shows a wooden log of mass 1 ton being pulled by a tractor on a rough surface. So here is our wooden log and here is our tractor. So in the first question, we are required to draw a diagram to show the forces that are acting on the block. So here is our block, and to show all the forces that are acting on the block, the first one, it is the weight of this wooden block. So there is weight that is acting vertically downwards, and there is also normal reaction acting in this direction, and there is also frictional force, because we are told that it is moving through a rough surface, so there is always a frictional force opposing the direction of the motion. So here we also have frictional force, and due to this tractor we have this tension in this string. Okay, so these are all the forces that are acting on the wooden block. We have weight, frictional force, normal reaction, and tension. Okay, and let us move on to the next part, which says suggest why force exerted by the tractor when pulling the wooden block on a rough surface is greater than when pulling the wooden block on a smooth surface. Okay, so according to Newton's second law, we say that the rate of change of momentum is directly proportional to force, and it takes place in the direction in which force acts. So With this Newton's second law, we then obtain this equation: F is equal to NA, meaning to say this F represents resultant force, and this M is for mass, and this is for acceleration. Okay, and we want to explain why the force exerted by the tractor when pulling the wooden block on a rough surface is greater. So the key point here, it is the force exerted by the tractor when pulling the wooden block on the rough surface is greater than pulling on a smooth surface. So for us to maintain a constant acceleration, we need to increase our tension here, because it is the resultant force between tension and the frictional force that is causing the acceleration of this wooden block. So we can now say it is tension minus frictional force being equal to ma. So for us to maintain this acceleration, we need to increase our tension, and the increase in tension, it is the increase of the force that is being exerted on the wooden block by this tractor. Okay, so to explain why the force exerted by the tractor when pulling the wooden block on a rough surface is greater, we can now say when the surface is rough, there is frictional force. Okay, frictional force, and frictional force, it is a force that it is a force that always takes place in opposite direction. Okay, so due to friction, there will be reduction. So there will be a reduction. In resultant force. Resultant force. And for us to maintain a constant acceleration, we need to increase the tension or the force exerted by the tractor on the wooden block. So you can now say for us to maintain a constant acceleration, we can now increase the force exerted by the tractor on the wooden block. Okay, and let us move on to the next question, which says calculate the acceleration of the wooden block when the force exerted by the tractor, it is 80,000 newtons, and the frictional force, it is equal to 65,000 newtons, and our G, the gravitational field strength, it is equal to 10 meters per second squared, and we are required to calculate the acceleration of the wooden block. Okay, so given that we are having this equation, F is equal to ma, and we understand that F, it is resultant force, and our resultant force, it is tension minus frictional force being equal to ma, and we want to find the value of acceleration. So our tension is the force that is being exerted by the tractor on the wooden block, which is equal to 80,000 newtons. So it is now 80,000 minus what is our frictional force? 65,000. So it is 65,000 being equal to our mass, the mass of the wooden block. What is the mass of the wooden block? It is 1 ton. Okay, it is 1 ton. So 1 ton is equal to 1000 kg. So here we can now say it is 1008. Okay, so let us subtract 65,000 from 80,000. So it is now 80,000 minus 65,000, which is equal to 15,000. So 15,000, it is equal to 1000 A. So let us divide both sides by 1000 for us to find the value of acceleration. So acceleration, it is equal to 15,000 divided by 1000. Okay, so it is 15,000 divided by 1000, which is equal to 15 meters per second square. So this is our acceleration for item 3 of number 9b. Okay, so this G here was meant to confuse you, because there is no vertical motion of our wooden block, so we don't consider G as our acceleration, and we are required to calculate the horizontal acceleration. So we are only considering the horizontal forces, this tension and this frictional force, and we exclude this normal reaction and this weight. Okay, so let us move on to the next part of our question, number 9, part C, which says state the direction in which pressure of a fluid acts. So pressure acts in all directions. So the direction in which pressure acts, it is in all direction. Okay, and let us move on to the next part of our question, which says explain why very small forces are required during use of a needle. So the idea that we are going to use here, it is the idea of pressure. So pressure, it is equal to force per unit area. Okay, so for us to have a high pressure, we should have a small cross-sectional area and a large force. So we are required to explain why small forces are required when we are using a needle. So small forces are required because we are having a small cross-sectional area for the needle, and this increases pressure. Okay, so the idea, it is of the increase in pressure due to the small surface area of the needle. So we can now say small forces are required because due to small cross-sectional area of a needle, there is an increase in pressure. Same for knife. When we are cutting something using a knife, the idea, it is of pressure. So small forces are also required when we are using a knife, because the small cross-sectional area of a knife, it increases the pressure on the body that we are trying to cut. Okay, let us move on to the next question, which says a dancer of mass 58 kg is balancing on heels on a dancing floor. The area of the heel, it is 6.4 times 10 to the power -5 square meter, and we are required to calculate the pressure exerted to the floor of the heels. Okay, to the floor by the heels. So pressure is equal to force per unit area, and the force here, it is the weight of this dancer, and the weight is equal to mg. So let us start by calculating the weight. So we can now say weight is equal to 48 multiplied by our g, which is equal to 10 meters per second square. Okay, so our weight, it is 48 by 10, and this gives us 180 newtons. So here is our weight, and we can now say pressure, it is equal to 480 divided by what? By our cross-sectional area, which is equal to 6.4 times 10 to the power negative 5. So let us divide 480 by 6.4 times 10 to the power negative 5, and this gives us 7.5 times 10 to the power, so it is 1 here, 2, so it is to the power 6 pascals. So that is the pressure exerted to the floor by the gills. It is 7.5 times 10 to the power 6 pascals. Okay, so this is our pressure, and let us move on to the next question, which says describe the construction of a Mercury barometer. Okay, so let us wrap this one, wrap this, so that we can write our answer. Okay, so we are required to describe the construction of a Mercury barometer. Okay, so a Mercury barometer, it is a device used to measure atmospheric pressure, and we have stages of constructing this Mercury barometer. So our first stage, so again name it stage 1, it is the glass tube. Okay, so for glass tube, a long glass tube about 1 meter is sealed at one end and open at the other end, and it is evacuated to create a vacuum inside. So the idea of this stage number 1 of collecting this glass tube is to use a long glass tube and open at the end, and also open at the other end, okay. In the second point, it is evacuated. So to evacuate is to remove air so that we can create, so it is evacuated to create a vacuum inside. Okay, and let us move on to the next stage, stage 2. So stage 2, it is filling with mercury. Okay, so the tube is completely filled with mercury and inverted carefully into the mercury filling basin. So the mercury filling basin, it is also called a reservoir. And then, okay, so this point for this second stage is to say the tube is completely filled with mercury. Okay, so this is the major point of the stage number 2, filling the tube with mercury. And let us move on to the third stage. So the third stage, let me use another color for this one. So here is our third stage. So it is the mercury column. It's the mercury column. So when inverted, some mercury flows out into the reservoir or the mercury filled basin. So this leaves a vacuum at the top of the tube, and the height of the mercury columns remains balanced by the atmospheric pressure pushing on the mercury in the reservoir. Okay, so the points for this stage of mercury column, we can now say when inverted. So when inverted, some mercury flows out into the reservoir. leaving a vacuum at the top. So it leaves the vacuum at the top of a tube. Okay, so there's another second point you can say here. So you can also say that the height, or you can say the height of the Mercury column remains balanced by the atmospheric pressure. It is atmospheric pressure pushing on the Mercury. So this pressure, it is pushing on the Mercury in the reservoir. So it's pushing Mercury in the reservoir. Okay, so let us move on to the last stage. So the last stage, it is stage number 4, the scale. Okay, so there is a vertical scale, usually in millimeters. It is placed along the tube to measure the height of the Mercury column. So we then put a vertical scale, and then put a vertical scale, and usually the scale, it is in millimeters. Okay, and it is placed alongside the tube to measure the height of the column. So the height of the Mercury column is directly proportional to the atmospheric pressure, and the standard atmospheric pressure supports the column about 760 millimeters high at the sea level. So this is essentially important to note that Mercury is used because it is denser than other liquids, and it doesn't evaporate quickly, allowing the manageable column height. So just to make sure you can recite these stages in their orders. The first one, we're having the glass tube, and along the glass tube we open at the end and they also open at the other end, and it is evacuated to create a vacuum inside. And then we have our second stage, filling the Mercury. So the tube, it is completely filled with the Mercury. And the third stage, it is when we invert some Mercury flows out the reservoir, leaving a vacuum at the top of a tube, and the height of the Mercury column remains balanced by the atmospheric pressure pushing Mercury in the reservoir. And the last stage, it is of scale. So a vertical scale, usually in millimeters, it is placed alongside the tube to measure the height of the Mercury column. Okay, so that is for this question, part C. It's part D of our question number 9. So let us move on to number 10, which says describe is defining the specific capacity. So we are going to define the specific capacity. So specific capacity, it is amount of energy that is required to change a unit, to raise the temperature of a unit mass of a substance by 1 degree Celsius or by 1 Kelvin. Okay, so it is of essential importance to differentiate between specific heat capacity and just heat capacity. So for specific capacity, it is for unit mass of a substance, and for heat capacity, it is just mass. Okay, so the major difference between heat capacity and specific capacity is that for specific capacity, we are considering a unit mass of a substance. Okay, so our definition, we can now say for specific capacity, it is the energy that is required to rise the temperature of unit mass of a substance, by 1 degree Celsius or 1 Kelvin. Okay, and let us move on to the next part of our question, which says, in an experiment to measure the specific capacity of a steel, a mass of 500 grams steel is placed in a calorimeter and heated using a 50-watt electrical heater, and after a period of 2 minutes, the temperature of the rivet rises from 10 degrees Celsius to 35 degrees Celsius. So we are required to calculate the specific heat capacity of the steel. Okay, and we know that energy, it is equal to MC delta T. With this E, it is for energy. So this one is for energy, this one it is for mass, and this one is for specific heat capacity, and this it is the change in temperature. Okay, so for us to calculate the specific capacity, we are going to make this C the subject. So it is now C is equal to E, the energy, divided by the product of mass and the change in temperature. Okay, so the change in temperature, delta T, it is equal to 35 minus 10. So if we subtract 10 from 35, what is our answer? And we get 25. Okay, so our change in temperature, it is equal to 25 degrees Celsius. And our energy, given that we are having this power of the electrical heater, so for us to calculate energy, we are going to use the relationship between power and energy. So power, it is the rate at which energy is delivered. So when we are saying the rate, we are simply meaning we are dividing energy with time. So power is equal to energy divided by what? By time. Power is equal to energy divided by time. And for us to calculate energy, we can simply multiply both sides by T to say energy, it is equal to power times time. And our time, it is 2 minutes, but for us to maintain units, we are going to change units into seconds. Okay, so 1 minute, it is equal to 60 seconds. Therefore 2 minutes, it is equal to 120 seconds. Okay, so our energy, it is equal to our power, which is 50 multiplied by 120 for seconds. So if we multiply 120 by 50, our answer, it is equal to 6,000. So this is 6,000 joules, that is for energy. Okay, therefore C, the specific capacity, it is 6,000 energy divided by what is our mass, it is 500 grams. And for us to maintain our units, we are also going to divide this 500 grams by 1,000 for us to convert it into kgs. So this gives us 0.5 multiplied by 25. Okay, so C, it is equal to, if we multiply 25 by 0.5, we will get 12.5. So it is 6,000 divided by 12.5. And let us divide 6,000 by 12.5, and we will get 480 joules per kg per degree Celsius, or per Kelvin. We can just say per Kelvin. So it is per Kelvin, like this. So these are units for the specific capacity of the steel. Okay, and let us move on to the next question, which says, state one assumption made in calculating the specific capacity of the steel. So one of our major assumptions that we have done in our calculation is to assume that there is no energy losses. So this calorimeter, it is not absorbing any of our energies. So that is our assumption. We assume that there is no energy loss. So the all of the energy that has been supplied by this electrical heater, it is converted to this steel. Okay, so let us move on to the next part of our question, number 10, which says explain why water is used as a coolant. So the reason why water is used as a coolant, it is because water, it has a high specific capacity, so more energy is being absorbed for a small temperature change in water. So to explain this, we can now say water, it has a high specific heat capacity, therefore it can absorb a lot of energy for a small temperature rise. Okay, so this is the reason why water is used as a coolant, because it is absorbing a lot of energy for a small temperature rise. Okay, and let us move on to the next part of our question, which says draw and label the heating curve of water starting from the ice. Okay, and the last part of our question, it is saying state one good and one bad conductor of heat. Okay, so for us to draw this curve, heating curve, we can start by drawing something like this. So here we are having temperature, and here we are having time. So here we are having a graph of temperature against time. So this is a heating curve of starting from the ice. So our ice, it is, let me use another color. So our ice, it is starting at this negative temperature, and then start to melt when temperature is equal to 0. So ice melts at 0 degrees Celsius, and then it will be something like this. And then after melting in liquid form, then something like this. And at this point, this one, it is 100 degrees Celsius. That is if this is a pure water and it is also pure liquid. Okay, and then after this, we're going to have something like this. Okay, something like this. Okay, and then also have something like this. Okay, so what we are having here, this one, there's an increase in temperature. So there's an increase in temperature until melting point. So our melting point, it is occurring at this point where we are having a 0 degrees Celsius. So at melting point, we are going to have this horizontal line, because when we are having a phase transition, there will be no change in temperature. So the change in temperature, it is equal to 0, because kinetic energy is directly proportional to temperature. So what is occurring on the phase transition, it is that all of our energy is being converted to potential energy, or it is used to break the covalent bonds within the water molecules. So this energy, it is only increasing the potential part of our energy, and then there's no change in kinetic energy. So if there's no change in kinetic energy, there will be no change in temperature. Okay, so this one, it will be a horizontal line, and there's also an increase in temperature like this. So this increase in temperature shows the increase in temperature in this. This is one, it is in liquid. This one is in liquid form. Okay, and this point here, our gas, our liquid, it is now boiling. This one, it is boiling. It is boiling point. Okay, so also we are having a transition, a phase transition here. So there's no change in temperature, meaning to say the change in temperature, it is equal to 0, because all of our energy is used to break the covalent bonds within the water molecules, and after we have boil our water, it then goes into gaseous state. So this is gaseous state here. Okay, so this is our heating cap. And let us move on to the next question, which says name one good and one bad conductor. So a good conductor, it is a metal. So metal conduct by delocalization of electrons, and those vibration with the delocalized electrons and those of vibration of the lattice ions transfer energy from a certain point to another point. So that makes metal a good conductor. And a bad conductor, we have wood. So in wood, electrons are localized within their bonds, so there are no delocalized electrons. So this is one good conductor, one example of a good conductor, and wood, it is a one example of a bad conductor. Okay, and let us move on to part C of our question, which says a pie chart in Fig 10.1 shows percentages of main energy sources used in mining town. So here we are having hydropower of 50%, solar of 20%, wood 50%, 15%, natural gas 5%, and we are required to determine the energy supplied by coal. So the energy supplied by coal, it is equal to 100% minus the percentage of hydropower, which is equal to 50%, minus the solar 20%, minus wood, which is equal to 15%, minus natural gas, which is equal to 5%. So the percentage of energy supplied by coal, it is 100 minus 50 minus 20 minus 15 minus 5, which is equal to 10%. Okay, so this gives us 10%. And let us move on to the next part of our question, which says state which sources are renewable. So a renewable source of fuel energy resources that are naturally replenished and can be used continuously without running out. So we do have examples of renewable sources of energies. The first one, it is the solar energy from the sun, and the other one, it is wind energy from the moving air, and the other one, it is hydropower from the flowing water, the biomass from the plant and the animal waste, and the geothermal energy from heat within the earth. So there are about 5 renewable sources of energy. The first one, it is the solar energy. The second one, it is wind energy. The third one, it is hydropower. So we have hydropower. And the fourth one, it is biomass. So biomass, it is a renewable source of energy. And the other one, it is geothermal energy. Okay, so these are 5 examples of renewable sources of energy. Okay, so in this question we are required to state which sources are renewable. So sources that are renewable here, we are having this hydropower, and we also have solar. So there are 2. Okay, there are 2, hydropower and solar. Wood, it is not a renewable source. Natural gas, these are not renewable source. Coal isn't a renewable source. Okay, and let us move on to the last part of our question, number 10, which says state 2. So we are required to state 2 advantages and 2 disadvantages of using solar lighting system. Okay, so the advantages of using solar lighting system, it is renewable, the first. So it is the most appropriate answer for this question. It is renewable and it is sustainable. So to use sunlight, it is abundant and it is free. Okay, so the first advantage for using the solar lighting system is that it is renewable and sustainable. Okay, and the second one, so let me use this color for advantages. So advantages, number 1, we are having it is renewable renewable and sustainable. Okay, and the second one, it is eco-friendly, so no carbon emissions or pollution, so it is free from air pollution, sound pollution, and so forth. So it is eco-friendly. It is the second advantage. And third advantage, it is low operating cost, so a minimum electricity bills after installation, so it reduces electricity bills. So our third advantage, it is low operating costs. And let us move on to the fourth one. So for the fourth one, you can say it have low maintenance, so it requires little upkeep. Okay, so it is also low. It requires low maintenance. So these are the advantages of using solar lighting system. And let us move on to the disadvantages. Okay, so for the disadvantages, we have high initial costs, so they are expensive to install. So you have high installation cost, high initial cost. Okay, and the second one, we can say it is weather dependent. So this one is obvious because the efficiency drops in cloud or rain conditions. So the major disadvantage of using solar lighting system, it is that it is weather dependent. Okay, so it is weather dependent depending on weather. And the other one, it is storage. It is energy storage needed. So there's a need of storage, energy storage, like batteries, because in nighttime there will be no sun, so we need to store the energy. So it requires batteries, or we can simply say it requires energy storage facilities. Okay, and then the last one, we can say it is space. It requires space, so it is space requirement. Okay, require space requirement. Okay, so these are the advantages and the disadvantages of using solar lighting system. So it is of an essential importance to recall these advantages and these disadvantages for this solar lighting system. Okay, and let us move on to the next